Yeah, I'm Adrian, by the way. Yeah. Has anyone? I just want to get a quick idea of what you guys do in this room. What's your like? What do you do at EPFL? Like, do you do computer science? Do you do math? Do you do like computer science? Anyone? Couple of people. Math? Anything? Something else? Okay. And also, like, what's your level? Like, bachelor or who's in bachelor here? Okay, most people. Master, maybe. Couple more. Okay, yeah. All right. So yeah, this is a more this is a like a more beginner oriented workshop. If you've never worked with Git, if you don't really know what Git is, or if you never really use GitHub, it's this one is basically for you. If you're confident with using Git and GitHub, if you've been using it for a while, it's a nice refresher, but you may not learn a lot of new things. But yeah, so to give a quick outline of what we'll see, we'll look at how we use, how we install Git, how do we create a repo on GitHub, how do you download it, use it, and how do you set up SSH keys to properly download repositories, but also how do you upload code to GitHub, how do you push changes, some GitHub features, and also like how do you do collaborative coding, which is the primary goal of GitHub. And if you want to follow along with the slides, either go to this URL, lozak.com/get-workshop, or this QR code as well. I'll leave it on the screen for a few seconds. Otherwise, lozak.com/get-workshop. So, and also, if at any point someone has a question about anything, feel free to interrupt, like raise your hands, or if I don't see you, like make a noise, whatever. Feel free to interrupt me with any questions that you may have. So yeah, first question, I guess, is what's GitHub? What's the difference between the two? So Git basically, it is what's called a version control system. A version control system, if you don't know what it is a system that is going to allow you to keep track of changes, make different versions of projects, of changes, like keep track of anything that is code related or just it can be used for a lot of things. So classic use case is, let's say that you've tried to work with other people on codes on projects or whatever, and you've been maybe sending snippets of code through WhatsApp or sending big code bases through like mails or stuff like that. It's not ideal. You probably run into a lot of issues with that. Use GitHub. That would solve pretty much all your problems. And so if Git is the protocol, is the system, is the version control system, GitHub is just a platform that implements this protocol. It's just a platform that allows you to collaborate easily on code and to host code easily. And it uses Git under the hood for version control and provides you with a lot of things, lots of tools and features. And GitHub nowadays is a pretty complete thing with like a lot of stuff, but most of what you'll need to use is like this button right there, pretty much. But GitHub has a lot of different features that we'll go over in a bit. So yeah, as I talked about a bit earlier, why would you use version control? And the answer is, well, for example, let's say I'm working on a big project where I'm working on like a lot of different files at the same time. I'm working on a lot of different features at the same time. It's pretty hard to keep track of all of these changes in a meaningful way where I can, for example, go back to your previous change. I messed up something, like my code doesn't work anymore and I don't understand why. I may want to roll back to your previous version. If you don't have a version control system, you would have to find the lines of code that you added and remove them. That would be very painful. With a version control system like Git, that's basically just one command or the click of a button. That's super easy. And that also prevents you from having a folder called version 1, version 1 final, version 1 true final, version 1 I swear it works final. It's a lot more convenience. And another thing also is that it's very useful for collaborating on code. So if you need to work in parallel with other people, with friends or with team members or anyone, it's just the best way possible to work with other people, and then you can all like work on a different part of the system at the same time, and then just merge your changes afterwards automatically, and it's not painful. It's just one like a couple of commands. So yeah, it's pretty convenient. And another use case, well, we say collaborators, but let's say it can be multiple me working on the project at the same time. Like I can work on 10 different features at the same time, and I'm not gonna break my codes if I use Git properly. I'm just gonna be able to have all of these features that I develop in parallel and that I can switch to effortlessly. And that is just like working with collaborators, except that I'm alone, right? So there are a lot of alternatives to GitHub. Like GitHub is not the only platform like this that exists. A notable one is GitLab. GitLab, although has quite a lot of paid features, but it is pretty convenient also because you can self-host it. Like you can have your own instance of GitLab that runs at home, for example. You also have stuff like SourceForge, Bitbucket. At the end of the day, they all do the same thing. They're all just platforms to collaborate and to host your code. And so why would you use GitHub instead of something else? It's just the most popular one. It's just like the one that is the most widely used. And yeah, there aren't really any other reasons to use GitHub over other platforms. It's just that GitHub is the most popular one, is the one that's most people use, and so it's good to use it. And it also has like lots of features, but most of these also implement these features. So it's just a matter of it's popular. So there's a bit of setup if you want to start working with Git and GitHub. And well, Git is a software, so you need to install it. It is really straightforward to install. So there you have a link to the instructions to getting started on installing Git. But that changed nothing, great. But also if you are like if you just type Git downloads yes on your browser, you're gonna first link is gonna be the one that you want. Then just go like on your operating system. Personally, I'm using Linux. So on Linux, it's gonna work a bit differently than, for example, on Windows or on Mac OS. I'm gonna use commands to install it. But on Windows, you can just like download the package. You can download the installer, run it, install it. It's pretty easy to install. And another thing that you may want to do to follow this workshop efficiently is to create an account on GitHub if you don't have one already. So you can just like go, the button is going to be over there. You create an account, and yeah, that'll be pretty handy for this workshop, let's say. Just give a few minutes. I don't know if anyone is currently installing Git or something. I'll wait for a few minutes until like everyone is done. Let me know if you need some time, basically. And especially for those on Windows, there's a pretty long setup that you have to go through to install Git on Windows. You can ignore 99% of the prompts that Git is going to give you. Just go next, 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 next until you're done, pretty much. You don't really need to do anything. I don't know if someone needs more time to install Git or like to create an account. Otherwise, I'll just continue. So now that you've created your account, now that you've downloaded Git, the next thing that you may want to do is to create a repository on GitHub. So this is pretty straightforward. You go on GitHub and you click this new button. And if you're not super sure about what a repository is, a repository is just a place online that is going to be hosting your code, pretty much. It's just like a place to store your codes online on GitHub. So there I can choose, if you have multiple accounts linked to your GitHub profile, which is my case, you can choose whatever owner the repository is going to have. We can give it a meaningful name, which is going to be Ubiquitous Spoon. That sounds like a very meaningful name. I'm going to give it a quick description, because why not? A very good repository. There you go. Then a couple of important prompts that we have there. So you can decide on the visibility of the repository, either public or private. If you choose a public repository, that means that everyone will be able to see it. It will be publicly available on your profile, and nobody will be able to do stuff on your repository if you don't allow them, but the code will be visible to anyone, and anything will be visible to anyone. And if you choose private, well, it's going to be private, and no one except for the people that you specifically allow are going to be able to see the repository. You can also start with templates, which are special kind of repositories with like special kind of settings. I've never really touched these, but they can be pretty handy if you create, like, I don't know, 10 different repositories that are the exact same. Pretty much you can create the templates and use it from there. Then another thing is that you can add a README or not, which we'll see what that does. I'll enable it. We'll also have a git ignore that I will explain what it is in a bit. Same, where you can choose a lot of templates. I'll go with Python because let's say that this is going to be a Python project. But for example, I don't know, you may have I know that there are some C++ classes. You have C++ templates. Just choose whatever language your project is going to be in from there. So let's go with Python. And then this one, the license. This is also, let me try to zoom in a bit. So the license is also a pretty important part. I have some slides. There's like git ignore. Yep. Okay. So the license. If you don't wonder what the license is, it's just a thing that tells people how they are allowed to work with your code. Like, let's say that you don't want to legally allow people to download your repository and use it for commercial use. You would choose this license that is specific for that. If you don't really care about it, it's still good to add a license if this is going to be a somewhat meaningful project. Reason for that, if you go to the website choosealicense.com, I recommend going through this website. There are a lot of very interesting information on it. And what happens if you don't have a license? Well, just like it said there, code is creative work, just like art would be, just like video editing would be, just like any kind of creative work would be. And that means that it's under exclusive copyright by default. So unless you have a specific license that says exactly how people should use your code, then your work is vulnerable to being taken down, to having some issues or having some litigations, or being used for malicious usage that could be like turned against you. So it's a good thing to add a license just as a safety measure, as a safety measure. Also because let's say that you start adding some other contributors. Each of these contributors has a copyright holder, and so if you didn't put a copyright on your code at first, well, you're not going to have the rights to use your code legally, your own code legally. So that can be a big issue, right? If you don't really know what license you want, a good one that is pretty general is the MIT license, this one. It basically just says that anyone can use your code for any use, but you're not responsible for what happens with your code. Like, you're not responsible if something breaks because of your code. That's not your fault. You're not responsible. So it's a pretty good license for just general like project that you just want to put on the internet, and that's it. So then we can create this repository. Once it's created, so you're going to have this view. You're going to have 3 files by default because of the options that we use. We have the git ignore right there. We have the license file, which legal text that you have some explanation about here. But it's pretty much what I said. Like anyone can use it for anything, but you yourself are not responsible for what happens, and you do not need to make sure that your code works. If it breaks, it's not your fault. And then you have the README. So the README, it contains the description that I put. It contains the title, the name of the repository by default. The README, if you go to any repository, for example, first one that comes to my mind is the curl, the curl repository, which is a very good tool. This is the README. It's basically just an explanation of what your project is. So there, it's a command line tool for transferring data from or to a server using URLs. It supports all of this. This is a great tool. And the README is just going to be the page where you explain what your code, what your project is, what it does. You can have some other files. Do they have some other files? Yes, they do. For example, you can have some other information files that have the .md extension for Markdown. If you've used that in the past, and like there it gives some info about how to use your project, things like this. So having a good README is a good thing because it just informs people how to use your projects efficiently. And if you want a very bad example of how to do a good README, of how to do a bad README, you have so this is where I store my configuration files. The README is very stupid, non-informative, but it's also, I don't really care about this project because it's not meant to be used by anyone else other than me. But don't do that, let's say. Yeah, so once you have your repository, you may want to download it. Like you may want to download it on your computer. And so you have this button right there that you can click. And bunch of options here. So let's go through them. You can download through HTTPS, through SSH, through the GitHub CLI, or you can just download a zip of the code base. It's like there, where is it? There. I'm just gonna have like everything that is in it. So most of the time you'll use this option. We'll go over how that works in a bit. But there's also another option that you can use that is not shown on my screen, which is this one right there, open with GitHub Desktop. So GitHub Desktop is a GUI. It's a graphical application that allows you to work with Git pretty effortlessly. It's pretty cool. However, it doesn't run on Linux. Thank you, Microsoft. So I cannot show it because I am on Linux. But if you want to use that one, if you're on macOS or Windows, you can download GitHub Desktop. It's pretty convenient. And so these other options, so HTTP, these are just two different ways to download your code. As you can see, when you click on this button, by default, it's going to put you on the SSH. On the SSH option, which is the one that is basically recommended. If you don't know what SSH is a protocol that allows you to remotely access resources like servers or things like this in a very secure way. It works using asymmetric encryption. Like if you've heard of RSA, this is asymmetric encryption. It's not going to use RSA in that case, but it uses these kind of protocols. And so if you've heard about if you've heard about SSH, it works using a system of private and public key. I'm just gonna show an example. So these are my SSH keys that I have on my computer, and I always have, for every SSH key that you have, you always have a private key, sorry, and a public key, which public key is going to have the .pub extension. The difference between these two is that the public key is the one that I can give my public key to anyone in this room. You'll not be able to do anything. But if I give you my private key, this is basically the password that I should never, ever share. So I can, for example, so to show exactly what it contains, like it contains just this is a protocol that it uses the protocol ED25519. It has a long string, and then this is my username and my host name, basically. And if I show my private key, you're going to be able to access anything. So I'm not going to do that. But it's going to contain it's going to be a lot bigger. And it's going to contain a lot of secure, it's going to contain a lot of information, not a lot of information that allows the connection to be secure. And basically, whenever if I show an example, I'm going to SSH into a server. Whenever you SSH into the server, my computer is going to send my public key onto the server, and the server is going to receive it and make a verification using information that it has stored on its computer. And it's gonna basically like decode a key that it has on the server using my public key. And if the decode matches what I claim I am, then I'm gonna be able to enter. And if not, then it doesn't. And this is it works using asymmetric encryption. Asymmetric. I cannot type, thank you, but I'm gonna be able to find it like this. Yeah, so asymmetric encryption. I'm gonna encode some data using my public and my private key, send it over to a server, and the server is going to be able to decrypt it using my public key. If this data was encoded using another private key, it's not gonna work. So like that's why this key I can send it, because it's what the server is going to use to decrypt the data. But this key is the password that unlocks everything. So never ever share this key, basically. So to create your SSH key, where do I have it? I have it there. Yeah, there are a couple of ways to create your SSH key, depending on your OS. So if you are on Linux, you are going to use a command that is known as SSH-keygen. So you run SSH-keygen. I'm not gonna do it because it's gonna overwrite my existing keys. You press enter a bunch of times, and it's gonna generate some files. If you are on Windows, you're gonna want to, yeah, it's always gonna be the same command like of SSH keygen, but I think on Windows it is not installed by default. So you will want to download OpenSSH, which is the so you go OpenSSH there, and there's a download button somewhere. Oh, probably, yeah. That's true. When on Windows, when you install Git, you're gonna have an app that is also installed that is called the Git Bash. If you search it if you search it, you're gonna have the SSH keygen thing. Yes. But what's the point of me generating this? So it's just yeah, I didn't explain it really, but once you have that SSH key, you can give your public key to GitHub. So like there, I gave a lot of public keys to GitHub, and with that, GitHub is going to be able to authenticate you. It's just you're gonna need to. So I closed the repo that I wanted. So if you want to make changes to repository or anything, GitHub needs to make sure that you are the one you claim, and so you need authentication that is just a nice way. Because the thing is, you're not making changes in your browser where you could have some other method of authentication. You're making changes on your computer, on like your code editor, where it's a bit harder to know who you are. And so having an SSH key just allows GitHub to know exactly who you are and that you are the one that you're claiming. So yeah, once you have the SSH key created, you're gonna want to copy it. You're gonna want to copy the public key to be precise. So I'm gonna run that. The command is gonna depend on your operating system. If you're on macOS, there is this command that exists, pbcopy. If you're on Windows, it's gonna be the clip command. But I think in PowerShell you can use the cat command as well. I haven't used PowerShell in a long time. And on Linux, there is a cat command that exists. So you're gonna want to open a terminal. On macOS, the app should be called Terminal. On Windows as well, on Linux, if you don't know how to open your terminal, I'm gonna be concerned. And then you're gonna want to go into actually you can just run this command right there. Just copy it and paste it, it's gonna work. So if I cat id e2 ed to this thing, there you go. I can just copy this thing. And then I'm gonna go to my user settings. So like I go up there, I go in settings, and I'm gonna go on this tab right there. And I'm not gonna do it because I already have this key on GitHub, so that would be a bit pointless. So I'm just gonna show here. You click on new SSH key. And then you're gonna have this prompt. You can just so you're gonna need to give a name to your key. This name can be anything. It's just an identifier for you. So for example, laptop or whatever you want. And then you can ignore the second thing, the key type, and you can just paste the thing that you just copied. The thing that you copied needs to look something like this. If it's a very, very, very long string with like lots of lines, that is a private key, and you shouldn't put that on GitHub. And it's gonna tell you that this key is not gonna work. So make sure that you have that you are printing the .pub file and not the file without the .pub, which I'm not going to do. I'm not going to print out because that's my password. And once you have that, you can just click add SSH key. It may ask you for your password, and because you're just adding a form of double authentication in some way, I guess. But yeah, once you have that, then we're all good to go for doing work on GitHub, on Git and GitHub. Yes. No, and then one SSH key is going to be for you can have one SSH key for every work that you do on GitHub. It's since you do it like in your user settings, it's not per repository, it's global. But as you can see, I have like a lot of different SSH keys. And the reason for that is because I have to log on a lot of different servers. It's like, for example, this key I use for GitHub, but this key I use for a virtual machine, this key for another virtual machine. It's just, you don't reuse the same password, right? Well, the same principle. It's good practice to not really reuse the same SSH key. And if you are doing that, I highly, highly, highly recommend looking into SSH config because that is just going to allow you to it's just going to set up SSH in a way that you don't have to specifically type out the entire key that you want to use for authenticating. So there I have a config file that says like, for this host name, which I can share because you're not going to be able to access this, I'm going to use this SSH key and this user. And if that is a bit more advanced, like if you just need to work on GitHub, you're not going to need that. But if you're starting to work with lots of servers, if you're starting to do some CI/CD stuff, like deploying stuff to servers, which I think is pretty cool, but it's outside of the scope of this workshop, you may need to do that. Once you have that set up, you can finally like click on this button and click on copy URL to clipboard. And then a thing that you may want to do is have a way to edit your code efficiently. For that, you use a code editor. There are about a billion that exist, but one that I can recommend that is really easy to use is Visual Studio Code. I'm pretty sure that EPFL recommends it, I hope, because it's just really easy to use. It's free, it's open source, it's just good. I don't personally use it, but if you need an easy one to use, this is a good one to go for. But you also have things like the JetBrains IDEs, for example, the JetBrains code tools, like PyCharm, which is the one for Python. You have some stuff that is browser-based, or like Replit, Spider. All of this is for Python, but you have many different IDEs that exist for any language that you want. Visual Studio Code is going to do every single type of language, so it's a good one to go for. And if you don't know what an IDE is, it's called an IDE is an integrated development environment. It's just a tool that is going to allow you to write code. but it's gonna have features such as syntax highlighting. It's gonna have things like you can easily go to the definition of functions or to the definition of variables. You can easily rename functions and variables throughout your entire code base. There are a lot of features. There are a lot of reasons to use an IDE over like something. I don't know why you would do that, but on Windows you could use Notepad, for example. Well, if you use something like Visual Studio Code, you'll have a much better time, and you'll also have like error detection. Like directly when you do something wrong, if you have a syntax error, Visual Studio Code is going to tell you. You can have debuggers, you can have a Git integration, and just lots of nice stuff. And I just want to go over a bit with the setup that I use, which this is a personal choice. You really do not have to go for this choice. Let me just go in the projects. I personally use a program that is called NeoVim, using a distribution that is called LazyVim. It works entirely in the terminal, and it is very like I don't need to use my mouse for edit code to edit code, and it's pretty advanced. So you don't need to do that, but if you're interested, look into NeoVim. It's really cool, and it also has some some GitHub, some Git interactions, some Git not interactions, some Git integrations that you can use. It's very complete. So let's open VS Code. Sorry for the flashbang. I put it in white because otherwise you don't see anything. But sorry for the flashbang. So on the start page of VS Code, if you install VS Code for the first time, we're going to be doing some Python stuff, like a bit of Python stuff today. So you're going to want to download a couple of extensions to support the languages that you want. So for example, for Python, you just type out Python and go for the official extensions. So like Python debugger, the stuff from Microsoft that has a small tick right there. You install all of that. It may take a bit of time, but it's gonna make your life a lot easier. But that is for Python. But for example, for if I want to do some I don't know, some Java, I don't know why I would do that, but if I want to do some Java, I can install the Java extensions. You'll need to do that for pretty much every language that you want to use, for reasons that are a bit more complex that I'm not really gonna go into. But anyways, so I'm gonna copy this URL again, and then I'm gonna click this button, clone Git repository, and it's gonna open this thing right there. I'm just gonna paste the URL in. I can do it from two ways here, either clone from GitHub or clone from URL. It's clone from GitHub is gonna need me to authenticate on GitHub. So I'm just gonna use this option. It's just more convenient. And it's gonna ask me where I want to put this repository. I like to put my GitHub repositories in this GitHub folder, but you can put it anywhere you want on your computer. Yeah.
So SSH key jet.
Oh, yes. Let me go back a bit. So, I'm gonna do that later. This is further. Okay. There. Which operating system are you on? Okay, so press the Windows key and type terminal. And the app should be installed by default, or it's if you're on Windows 10, it's gonna be CMD maybe. And then you can if you have the slides open, you can just copy that command right there. Or Solal can help you. Yeah, thank you, Solal. And yeah, so this command, I didn't really go over it, but this command basically is it's just gonna print out what is in a specific file. The clip command on Windows CMD is going to print out just gonna print out the content of a file, or the cat command on Linux is going to print out the content of a file. It just depends on what OS you're on. And also, I didn't talk about that, but let's just talk about the differences between these three buttons. So if you go over HTTPS, it's going to be, so all of these three are basically like three different protocols. or like these two, I guess, HTTPS and SSH. There are two different protocols that you can use that are used for different things, and you can clone using SSH. Using HTTPS is just going to be less secure, and you're gonna need to type out your password. Like if I go here, gets clone, and I paste this. Oh, it worked because it's public, right? But let's say that I have a private repository. Then a private repository means that I need some authentication to get in. And if I use HTTPS, it's gonna ask me for my username and my password. It's not gonna be very convenient. And also it's simply not gonna work because I have multi-factor authentication enabled in my account, which is it's not gonna be able to get that double authentication. So use SSH is just convenience, and I think I'm pretty sure that GitHub is going to retire the HTTPS option. Either they're working on it or they're going to do it soon. SSH is just infinitely more secure and infinitely more easy to work with once you've passed that barrier of setting up the SSH key. So there we go. Let's go back to where we were. Okay. So once we are on VS Code, we're just gonna paste out the URL. Wrong one. This is this one. We're just gonna paste out the URL. You know it's an SSH URL because it starts with git@github.com, and since SSH is a protocol that is used for a lot of other things than for GitHub, you're gonna see some different formats of URLs. For example, this could be gitlab.com. And it's always going to go like, this is my username and this is my repository.git. So there you go. I'm going to put it, as I said, in the GitHub folder. Personal choice, you don't have to do that. It's going to load for a bit. And then I'm going to click on open. So, and yes, I trust the authors of this file. So is no one able to follow along until now? Yes. Yeah. It's gonna upload it once you tell it to upload. Yeah. But there aren't any, it's not really convenient to edit code in the browser. You could, like you can go on GitHub and go edit. But you're going to be missing out a lot of features of VS Code because it would just be too heavy to run on a browser. So yeah, really the best way is just to download the repository locally, to clone it, which is the technical term, and then to edit it here. And I just said that the technical term is cloning. So I'm gonna be showing everything through the VS Code UI, but you may also want to use the terminal for that. If you use the terminal, which I'm just gonna open here, you can clone repositories using a command, because Git by default is a command line interface. So I'm just gonna type out git clone and then paste that URL. And I already did it, so there's no point in doing it, but you could do it through there. You could type out git clone and whatever. There are a lot of benefits of using the command line over using like a GUI, over using a graphical interface. Main one being that your Git is an extremely complex software. In this workshop, we're going to be using like 5 commands at most. But overall, I think Git currently has over 160 different commands that are used for different things. So Git is very complex, and you cannot implement all of these features in a graphical interface. So if you want to have a lot more power and a lot more control over what you do, use the terminal. If you just want to use the basic features of Git, then graphical interface is very good. So there you go. So now I'm in my repository, and as you can see, there is the exact same contents that I had on GitHub right there in my codes. And so I guess we can start doing things locally. Like right now, this is something that is in my computer. So this is not a very good repository. This is an extremely good repository. I'm just gonna save. So a couple of things happened there. Actually, yeah, So there were a couple of changes on the UI. There is this M that appeared there that is also there. There is this thing that appeared there that tells me that there was a changed line, and I can like this is no, this is just because of the markdown. And there is this one that appeared there. So I guess let's go on this tab first. Let's go right there. So this is the UI that you're going to be using in VS Code if you want to work with Git. So there were a couple of buttons here, but basically Git saw that I made a change in this file. It saw that I removed variant that I replaced with an extremely good repository. And now there are a couple of things that I need to do. So right now, Git saw that I made some changes, but it doesn't know exactly what changes I want to be on the. It doesn't know what changes I want to be saved in the end. Like, let's say that, for example, I change. I'm just gonna remove, for example, this line because why not? There, it's gonna tell me about. It's not gonna tell me about this change. Okay, let's make a change in the license then, which is not because I didn't save whatever. But it's so there is gonna tell me that I made changes in these two files, 3 files actually. But let's say that, for example, I didn't want to do that. Like that was an accident. Oops, I messed up. Happens. Then I can just click this button right there to say that these changes I want to discard them, and so I can click discard, and it is going to restore the state of this file to whatever it was in previously. So before I added this nonsense, which is pretty convenient. So like if you mess up on anything, you can just go like, nope, I'm going back to a stable state of the repository. But now like these 2 changes, I'm pretty confident in them. I think that they are good changes. So I am going to click this button. This button stage changes. This button is going to tell Git that this change is change that I want Git to keep track of. This is something that Git is going to remember. That's, oh, there is this thing right there that was added. And if I don't want Git to keep track of it, I can press this minus button, and it's gonna come back in that list. But let's do that for now. So there we go. Now, so I made this change. I told Git that it's something that I want to keep track of. Now I would want to upload it on GitHub. And uploading on GitHub it happens in 2 steps. The first one is using this button right there, commit. Basically, I told Git about these changes. Now I'm gonna compact this change into a package, a commit, and then I'm going to send it over to GitHub. So this change, I'm gonna give it a name, change readme. There you go. Then I'm gonna press commit, and it's gonna disappear from here, and it's gonna appear here. And this means that now this change is packaged. My feature is done. Whatever I was working on is done. And then I'm gonna be able to upload it to over to GitHub. And I guess let's go through there. There are a couple of ways to do that. So yeah, commit and push, whatever, and we'll go with that. So if you click there, you can click commit and push, which we already committed. So it's just gonna push whatever change was. What did I do? I did something. No, I see what it did. Okay. Okay, so yes. So when I push, I'm gonna refresh the page. There, pushing means that you upload the changes on GitHub, pretty much. So yeah, so a commit is you always need a commit to be able to. Okay, so a commit is basically going to be a snapshot of your code base. It's going to be at this commit, my code base looked like this. It was stable, whatever. And now I can work on something else. It's changes that are now you can now revert to. You took a snapshot of your code. You took a backup of your code. That now, if I want, I can go back to and change or do anything. Sorry. Yeah, yeah, pretty much, yeah. And these commits are going to appear in the GitHub UI right there. There is whatever I did there, and there is change README. And if I go over, if I click on this commit, it's gonna show me that I changed this line to this. And so all these packages that I created, all of these commits are going to be uploaded over to GitHub. So let's see, where are we? Yep. And let's do another change to give another example. So now, so it is an extremely good repository, but I want to add some more details to it. For example, repo used for, let's go. This is pretty meaningful. This is pretty useful information, I guess. So like I'm gonna press this button right there to stage the change, to tell Git that this is something that Git should keep track of. Then I'm gonna now I need to package it into a thing that's into a snapshot of my code, and I'm gonna name this change, which commit messages should be meaningful information. It's what is going to be shown in there. So it should be meaningful information. Like, for example, this is a very bad commit name. This is a very bad commit message. And if you want another very bad example, let's go back to there, where you can see some interesting commit messages. Again, I'm doing that for my thing, but like, don't put a dot as your commit message, because this is very undescriptive. If I come back to this code base like in a year, what is this? And even today, like this was a few months ago, I have no idea what this was. So I guess let's see. I changed the file. Okay. I deleted the file. Okay. Well, this commit should probably have had the message deleted this file for whatever reason. So there we go. Now I'm gonna gonna add some more information, and I'm going to commit and push. And now if we go back there, it's gonna appear right there. Perfect. And now let's say that someone else tries to wants to use my code. So they're gonna clone it. They're gonna clone it at this state of the code. They're gonna clone it at the latest state of the code. And there are ways to clone for example, let's say that I want to clone this very specific commit. There are ways to do that, but we're not gonna go over that. It's a bit more advanced. But if I go there, it's going to download this very specific version that contains this. So there we go. If you also if you're more comfortable with the command line, which I am personally, there are a couple of commands that will basically do the same as what we have in there. So let's say that we make a change, some change. It's going to appear there. The command that is corresponding is called git status. If I run git status, it's going to tell me that I am on branch main. We'll just see what that means in a bit. That my branch is up to date with origin main. That means that my branch is up to date with whatever I have on GitHub. And then I have this change, which I modified README, and it puts it in red because it doesn't know about this change. I didn't stage it. And to do that, I'm going to use the command git add. So we're going to get git add, whatever file that is. And then we're going to, that's M, I think, yeah. We're going to use the flag -m. So I'm going to say git add readme, and I'm going to add -m and type a message in here. And wait, git add, no, never mind, ignore me. So git add. There it is going to stage it. This is the same thing as clicking on the plus right there. And then once I have done that, I can git commit it and give it a meaningful name. So I'm gonna type git commit -m and some quotes, and this is going to be whatever I type in there. So did something else. Very meaningful change. And now to push it, I have this sync button right there, sync changes. I'm gonna use the command git push. I type it, I press it, it's gonna do some stuff, it's gonna give some information, and the commit is going to appear there. And that basically comes down to whatever you're more comfortable with. I am personally more comfortable with the command line, but if you are more comfortable with this UI or whatever UI you have on GitHub Desktop, that's completely fine. At the end of the day, 99% of your work on Git is going to be using git status, git add, git commit, git push. If you want, like the minus that I had to, like let's say that I want to revert this change right there. So I'm gonna add it. If I want to press this minus, this is the equivalent of saying git restore. And I can also, this is also an interesting one. So there I have some changes. I'm gonna type git diff. Git diff is gonna show me this UI is gonna tell me that I removed some change and that I added this. And if you remember, this is basically the equivalent of clicking there, where I'm gonna have the same thing but with a graphical interface. Yes. Staging is just telling Git that this change is important to keep track of. To create a commit that contains changes, you need to add you need to stage the changes into the commit.
So you're telling it like you change something in this file and like keep it in mind for next time.
Yeah, exactly. And whenever you create a commit, it's gonna package anything that you added there that you staged, and anything that you did not stage, it's not gonna commit it. Yeah, okay. So I'm just gonna restore this file. I'm just gonna discard this change, and I'm gonna create another file, main.py. There you go. Okay, and since this is a new file, I was gonna show something else than what was the M that was there previously that said modified. It's gonna say a U for untracked. This U means that Git has never ever seen this file. Even like previously it said an M because it knew about the README file, for example, but main.py, I just created it, Git does not know about it. It's just a different indication. At the end of the day, you just press this plus button. So like I press this plus button, created, and actually we're not gonna do that now because we're gonna add some content into it. First of all, we're gonna add parents, hi. There we go. And I'm gonna stage this change. It's gonna be added to the commit, created main.py, gonna commit it and push it. And there we go. And now we finally have something useful in this repository, other than some meaningless files there. I have this main.py file, which has print hi Lozak. And now this is a good moment to go a bit over the GitHub UI. So whenever you're on the page of repository, and this is going to be the same except for like couple of details for every repository, there is going to tell me exactly what language this code base is in. So this is 100% in Python, but if I go back to GitHub, that was sure. Let's go to the Cloudflare code base. There it's gonna tell me that it's 90% Go, but it has some Python, has some HTML, has some shell. This is pretty convenient. And if I click on there, it's gonna show me exactly what files are in Go. So there's that. There it also tells me who contributed to this website, to this code base. So if I go to another repository that has some contributors, which is the Lozak website, there, as you can see, there are many people that contributed to this website. They're all listed here. This is everyone that has done a commit on this repository. And then the more useful things are on top. So let's say that you're working in collaboration with other people. Your people are gonna find issues in your code. People are gonna find problems and like bugs, whatever. When you find a bug in some software, a good thing to do is to open an issue on the repository, which is just a way to tell the owner of the repository, hey, there is a problem here, or hey, I would like this feature to be added. So if you go to this tab to see what there is, so for example, we can say that there is a bug and whatever this is, and the person described the bug, describe how to like reproduce it, whatever. So there is this tab. So we can go to the issues tab and we're gonna create a new issue. Bug in main.py. There you go. There is a bug in main.py. Main should print hello instead of hi. I know, a very big bug, but it's possibly a bug. And there, this is really a way to communicate with the owner of the repository. So if you do that on a public repository that has a lot of code in it, that is very active, make sure that that whatever you write in there is as descriptive as possible. Like give as many details as possible. This is a bug report, or this is a feature request. Like if you do feature requests, well, I'm gonna say why I want it. Like I'm gonna say what I want and why I want it. So I would want to be as descriptive as possible, so the person has a lot of details, right? So we're gonna create it, and there you go. It says that main.py should print hello instead of hi. And now the owner of the repo has been notified, and he can work on it. Like I can work on my own issue, or whatever. And this is also like a good way to just keep track of whatever I have to do. So I can create an issue to say I still need to add this feature. I can create an issue to say I found a bug there, whatever. This is good to keep track of your own things. And then there is this tab right there, which we'll talk about in a bit. So I didn't mention that for now, but I mentioned working on 10 different features at the same time earlier. And if you always have to go, okay, so there is this change, I'm gonna make another change. This is not very convenient. Like there, well, I'm gonna resolve that issue. It's gonna be hello. But now I'm basically like on one path where if I start adding some other feature that may break some other part of the code, it's not gonna be very convenient to work on multiple things at the same time right now. So what I can do, and I can click on this button right there, and I can create a new branch. So we're gonna create a branch, and main.py fixes. There you go. So I created a branch. As you can see, it used to show main, now it shows main.py fixes. And for now, we're just gonna publish it. And publish it means that I'm gonna create the branch on GitHub. So now, as you can see, it says that there are 2 branches, and I can go to main.py fixes. Now, what is this? I'm gonna give an example to show exactly what this is. So I'm gonna make the change. I'm gonna stage it, and I'm going to commit it. Changed main.py to resolve first issue. So I commit it. Okay, so there it's different. Some colors changed. There were a couple of things that were changed. This is just that it shows me that there I was on a different branch than I was right now. And I'm just gonna go back to this branch to main, and I'm gonna make a different commits. And as you can see, this is pretty, so like different branch is just going to be a different path, different thing that you're working on that has nothing to do with the other thing, with whatever other thing. So there I'm gonna create another commit where instead of hello, I'm gonna, so before we said that this was hi, we said that this was hello. Now we're gonna say that this is sup Luzak. There you go. I'm going to add it. I'm gonna add a message. Changed main.py. I'm going to commit it. And it doesn't really show the graph very well on there, I guess. I'm just gonna I'm just gonna show it on GitHub, I guess. I don't use this very often. I don't use VS Code very often, so unfortunately. So we're gonna be able to see what I mean here. So there I pushed, and I'm gonna go back to main.py fixes, and I'm going to sync. Okay. So there you go. So now I have my two branches right there. I have main.py fixes that has one commit on it, and I have main.py which has another commit on it. And as you can see right there, you can see that there's a path that diverged. Like before, I was on the same path. Now I created basically a new split of the code, a new branch where there I'm gonna work on some feature, and then I'm gonna work on some other feature. And you can create as many branches as you want, and whenever you want. Don't really do that, but if you want, you can create like 1,000 different branches, and it's gonna show in a nice graph like this, where we really see that this is really two different things. Like if I go to there, if I go back to the main branch, we have sup Lozak, and if I go over to main.py fixes, we have hello Lozak. So we really have two different code bases now, and I'm gonna be able to merge it later or do some other stuff later. But anyways, so we are yeah, okay. So like now I made some changes there and I made some changes there. But there's a thing there where I made some changes on this file, but this branch right there, it doesn't know about these changes. Like it knows about other changes, and I changed the same line of code. So something weird is gonna happen when we try to merge the code base, when we try to resolve everything. So if I go to yeah, okay. So just gonna use the command line. I'm sorry, I don't know how to use this UI. So we're gonna get check out on the main. So the commands for changing branch on the command line is called get checkout. There is also git branch. There's I think another one that git switch that exists. I use git checkouts. You can use git switch, git branch, git checkouts. Look up the documentation for it. And I'm gonna go get no, I actually need to go on the other one. I'm gonna go back to main.py fixes. So right now I am on main.py fixes, and now what I want to do is that I want to take that branch and put it back onto the main branch, like have it be again following the main branch. So we're gonna do a git merge main. So like I go git merge and the name of the branch that I want to merge into. Okay, it didn't allow me to do it. It says that there is a merge conflict in main.py, and that's if I want to continue, I should fix the conflict and then commit whatever I did before. Because here's the thing: if I go to whatever I have here, so Git is smart. Git is very smart, but here I have two changes on the same line of code. And I didn't tell it how to solve this, and it doesn't know how to solve this. I am the one that knows how to solve this. And so whenever there is a conflict, Git is going to modify your file. Like these lines really exist in the file right now. There's like this head, there is this main, and there is this separator in between. And this is basically going to say that this is what is on the branch I was trying to merge into. Hello, Luzak. This is what's no, actually no. Actually no. This is the opposite. So this is what is on my current branch. So on main.py fixes, I have this right there. I have hello Luzak. On the branch main, I have stop Lozak. Now I need to tell Git how we're going to do this. And as you can see, there are a couple of buttons here that appeared, and there's also this button here, which is a really good one to use in this context. So there it puts me, it gives me the two views. So this is the incoming change. This is whatever it was in the main branch, and this is my current change. So well, now I have to decide, what do I do? Do I keep this one? Do I keep this one? And in that case, we're gonna accept this one because this is what I wanted to do. And now I'm just going to complete merge. And now we're back to a stable state where hello Lozak, like this file contains just one thing. And we're gonna continue and sync the changes. Yes.
So if you weren't using VS Code, how would you have access to this?
Okay, so the conflict resolution, I wouldn't have it like it's a tool that exists on VS Codes, but so the thing that's the things that appear before, like the heads and main, these lines really are in my file. So to resolve this, I would want to go into my file in whatever editor I'm using. So for example, NeoVim. I want to go into my file, remove these lines, make the codes be something that I want to be, and then I will be able to do git add, git commits, and git merge, and git push. Sorry. And yeah, and so now if we go over to the repository, taking a bit, and change. Did I push the thing? Let's see, did I push it? Did I push it? I didn't push. Why is it not showing? What isn't there? I'm not sure why I didn't change it. Let's see what's in there. So main.py. Hello, Luzak. The merge didn't work? What happens? So let's do it again, I guess. Git merge main. Okay. So now it tells me that there is a conflict, and I guess I'm just gonna use this. I'm just gonna go to show the other approach. GitHub and because spoon -1. Okay, so there, and if you can see down there, it says that I'm currently in a state merging. This is my conflict that does that. We're gonna go into the main.py file. This is embarrassing. Am I in the correct branch? Oh, I guess it just happens. Stage main.py until next resolution. Okay, so I'm not sure what happens, but okay. So I click continue, I click sync changes. Please work. I did that already. This is not working as I want. Let's go in there. Git merge main. Okay, so I have some changes. Okay, let's just see how we did it there. So there I have this repository where I have something. I am on a specific branch. I am on the main branch. Then yeah, okay. So from another repository, from another place, I tried to change some stuff and to push as well, and it told me that there is a conflict right there. So this is this is what it's going to show. Like there is head, this, and there is this thing or main or whatever. So I'm gonna resolve the change. So like, for example, we're going to accept the current change or incoming change or both change or just compare them. And then, yeah, once I've done that, I need to add the file. And yeah, that's pretty much the conflict resolved. And if it works, which I have no clue what happens, why it didn't work, it's gonna show somewhere in there, and it's gonna like main.py is gonna contain hello instead of sub. I guess let's make a pull request. Okay, yeah. So another way to go through this, I'm not sure what's happening there. Another way to go through this is so there, GitHub is telling me that I have some recent changes, some recent patches on the main.py fixes branch, and it's asking me if I want to do a pull request. Pull request essentially is a way. Pull request essentially is going to show there. It is a way to work on a change and then suggest the change to the owner repository. So what I could do, let's say if I had good access to this code base, I could clone the repository, create my branch, and work on whatever I have. I can push to the branch, and then I'm gonna be able to create a pull request, which the name is very bad, but a pull request just means that I would like to merge the changes into the code base. So like there, I have the title, and I can see that there I cannot automatically merge because there are conflicts. So I'm gonna create a pull request, and there I'm also gonna add a small description of what my changes are. It's like the title is just like a one sentence thing that you add, but my description, this will resolve the first issue, whatever. The idea as well here is to make sure that this is as descriptive as possible, to make sure that the owner of the code base understands why you did this change. I'm gonna create a pull request, and now something is going to appear there, and now the owner of the repository can go on there and say, okay, so this person had this commit. They changed hi Luzak to hello Luzak. So there's one file change. Like let's say if I had 15 commits, it would show every file that I had changed there. There are also some automated checks that I have on my account. And now also another interesting thing is that I can review the changes, and I can, as the person that maintains the repository, I can go, okay, so you did these changes, that's pretty good, but there is an issue there. And I'm gonna be able to leave a comments on the pull request to ask for changes. And I'm also going to be able, let's say that I want to make comments on this thing specifically. I can just press this plus button, and it's just gonna show there. And so a pull request is not something that you're gonna have locally. It's only something that is going to be on the repository. So this is all that I'm doing there. You're not gonna be able to see it locally. And then, so there were some conflicts, and it's telling me that there were some conflicts. Let's try to resolve them. Okay, so there we have the same UI as before, just the difference. We said that we wanted to accept this change, which is the current change. So I'm just gonna accept the current change. There we go. I'm gonna mark it as a result. So like this conflict is good, and I'm gonna continue the merge. Okay, so there, yep, now it's saying that there's no more conflict with the base branch and that the merging can be performed, because I just told Git that this change, like this one line is not gonna cause conflicts, because I want to change it to that. I don't know if that's understandable, since I kind of messed up. Yes. I'm gonna come to that in just a second. It's not updated right now. And so now that I did that, now that the conflict resolved, I can press merge pull request, and I can confirm the merge. And there we go. The pull request has been merged. And now if I go to main.py, it says hello Luzak, and I am on the main branch. But yeah, very good question. So when I do still have two branches, yes. And it doesn't delete the branch. It just takes the content of it and it puts it on whatever you decided to merge with. And a good thing to do, like a good practice to do, as well, since these branches stay, to delete them. Like this was used for this pull request. I can now delete this branch because if I keep all the branches, it's gonna pollute everything. Is not gonna be ideal. So like now, I just deleted the branch, and all of this, all that I did there happens on GitHub, and I didn't do anything locally. As you can see, if I go, let's close this. If I go to main.py here, I am on the main branch, but it still says Sablozak. So I'm gonna need to pull I'm gonna need to do what's called a pull operation. I'm gonna pull the changes from GitHub to my repository. A couple of ways to do that. The one that I am comfortable with, I think you can click this button maybe or not. Okay, I'm not sure. But what I'm comfortable with is a command called git pull. And git pull is just going to, well, take whatever was on GitHub and put it in my file. And right there, it's giving me a small summary of what happens. So we pulled from this repository, and it changed main.py. It removed a line and it's added one, and one file change, whatever. And now if I go there, hello Lozak, everything is good. And now that this change is resolved, I can go into this issue right there, and I can just say, I can just add a command solved, and for that, so every commit has a unique ID, has a unique identifier. It's right there, this number right there. I'm just gonna copy it. I'm just gonna copy this number, because I'm going to reference it in this issue. I'm gonna say that this issue was solved in this. I think you have to put a hashtag here. Yes, there you go. It's gonna so I put the ID, and it's gonna automatically like show me that this is this commit, or like #2, I guess. Yeah. Or if I just put this somewhere, it should work. I think I comment it, and yeah, it's gonna automatically link to the repository. And now I can close this issue because this issue is no longer relevant. And so now it tells me that there is no more issues, but that there is one closed. So if I want, I can open it again. Do I have anything else I wanted to? So branches, yes. Yeah. Yeah, another thing that I guess we can go over. This repository right now, I didn't give anyone access to it. I am the only one that is able to make changes to this code base. And it's a pretty irrelevant code base, but let's say it grows quite a lot. I may want to add a collaborator on it, or let's say it's a project for a class. It's good to have people that can work on it. So for that, I'm gonna go to the settings tab, not the user settings this time, but this the repository settings. I'm gonna go to the collaborators tab. It's gonna ask me for my passkey. And there, I'm gonna be able to add people. So for example, we're gonna add, is that your name, Solal? Yes, it is. We're gonna add Solal to the repository. And now, so now Solal has received a mail or notification, depending on when he set up. He received a mail on his mailbox that tells him that you received it. Good. I added him as a collaborator to this repository, and once he accepts it, can you accept it, please? Oh, whatever. Okay. So whenever he accepts it, he is going to be able to do whatever he wants on the repository. He is going to have permissions to make changes on there. And so this is what you need to do if you want to collaborate with people on that. Yeah, but let's say that now. Okay, so Cloudflare, there. I found a bug in this code base. Let's say that I found a bug. What if I want to solve the bug myself? What if I want to go, okay, so I found this bug. I know how to resolve it. I'm just gonna do it myself, right? I don't have push permissions on there. I cannot create a branch on this repository. I don't have permission. there is this feature in GitHub that is called a fork. So let's create a fork. A fork is a special repository that is going to be based on another repository. So in that case, it's going to be Cloudflare. I'm going to create this branch. I'm going to copy this branch. And I'm going to create this fork. It's going to take a bit because it's a big code base. But once it's done, there. So I have the entire code base of Cloudflare, except that it is on my account. It is my things. And now I can clone it. This is probably a very bad idea. This is going to take a while, but let's try. So I'm going to do git clone this URL. And as you can see, it says link 10183, so my username / Cloudflare. So it's in my account. And there you go. Now I have access to the Cloudflare code base. And if I make changes, so for example, let's change, let's do something that is going to break stuff. I'm gonna go in there and I'm gonna delete this line. There you go. And now I'm gonna go git add. So there is a shortcut. If you don't want to type out the name of the file that you want to add, you can do git add dots. So like the dot is just going to say git add everything. So git add dots. If I do a git status, it's gonna tell me that I modified the go.mod file. I hope this is visible down the screen, by the way. Let me know if it's not. So I modified this. I'm just gonna commit it now. This is a bad idea. There you go. And I'm gonna push it. Okay, there you go. So now I go back there. And as you can see, now it says that this branch is one commit ahead of the master branch of Cloudflare. And another note, you'll see, so the first name, the name of the first branch when you create a repository will be main in 99.999% of cases, but it used to be master. It was changed because master has some slavery implications, right? So it's not great. So on a lot of older repositories, you'll see that the main the main branch is called master. That's just yes.
Because the other day I installed Git on my computer and it defaulted to this.
Oh, it defaulted to this. So in your case, you're gonna want to change the git config. Are you on Windows? I don't know how you can change that easily, honestly. But if you in your home folder, so c/user/your username, you're gonna have a .git config file. And in there, I have a lot of stuff. Yeah, there you go. Default branch, this value right there, you can change it to main. And it's not gonna change the branch name of any of the repositories that you create, but it's going to change the main branch name of other repositories that you create. And if you want to change the name of a branch, it's possible. I don't know on top of my head, so let's just look it up. Rename branch. Because that's also something that's great about Git is that Git is old. Like Git is one of the oldest version control software that there is. It's not the first one, but it's a very old one. And so there is about a lot of documentation. So like there it just tells me that I go git branch -m old name new name. So that's exactly what I'm gonna do. I'm gonna go over to my repository. Do I have it there? Yes, I have it there. So I want to rename the main branch to main2, for example, for the exercise. I'm gonna go git branch -m, and the old name was main, and the new name is gonna be main2. And now it's telling me that it's main2. The reason why it's showing main2 and main, if I do a git status, yeah. So the reason for that is because this is linked to a GitHub repository, and the branch name on GitHub is main, not main2. But yeah, and also if you're someone that uses AI a lot, ChatGPT is honestly great at solving Git issues. It's super. It's like it's yeah, and because there is one thing that's also pretty convenient about Git. So I said that there are like 160 operations on Git. I don't know the exact number, but there are a lot of operations. Let's say that I mess up my code base in some way. There's always a way to restore it. Always a way, and the way is probably going to be is maybe going to be complicated, or it's just going to be one command that you just don't know about. Go to ChatGPT because that's just going to find the issue in 2 seconds because there's so much documentation available. But where was I? Yes, we had this branch right there. So now I did this commit that is going to break things. So why not give this very nice change to to Cloudflare? Say I have this very nice change. I have this very nice change from my fork on GitHub, and you're not gonna be able to do this from Git, so you need GitHub for that. I'm gonna click open pull request, and I'm not going to create it because otherwise this is going to this is not a good idea. But there I can go like this is a bad idea, and I can say why this is a bad idea. I removed a module from the go.mod file. It's not gonna compile. There you go. And make sure that this is very descriptive. Like don't write like I did. This is a bad example. Just write clearly. Make sure that this is clear. Then I'm gonna create pull request, which I'm not gonna do. And from there, what's gonna happen is that if we go to the main repo, the main thing, so a pull request is going to be open there. And so there's this. There's no discussion on there. Can I have one that has a lot of discussion? This, for example. So there, person described the change, and then like they added some more comments because you can also add other commits to your pull request, and so the person added some more stuff, and there, okay, good case there. This person requested opinions from another person. So like MetaDaddy requested a change from Devin Carr. These are real users. And he asked for a review on the PRs. So let's check the review. I don't know if he added any comments anywhere. I guess not. I guess he didn't. But if I wanted to, I could go. This line is bad. Which I'm not going to do. But with this, you can really have a conversation with the owners of the repository. They can ask for some specific changes. They can go, okay, so this is an interesting idea, but we should more orient this towards this. And this is just the idea of open source. It's just collaboration between lots of people. And then once the changes have been approved by everyone, as you can see, Kornalski approved these changes on October 6, 2024. Once maybe some criteria have been passed, the person is going to be able to merge the pull request. And this is not the person actually, like the owners of the repository. And once it's going to be merged, everyone will have access to this change. And is there anything else interesting that we can talk about? Yeah, this is a pretty cool one. If maybe you're using something like a Kanban board to keep track of whatever work you have to do on your repository, I'm just gonna create an issue there. Random issue. I'm just gonna create this there. So like if I go to this tab there, projects, I can go new project. And there are a lot of templates. I'm gonna use a Kanban board, for example. There is gonna allow me to import issues from repositories, which is why I created an issue. And there we go. So like the issue that I created there is now right there. And this is really like a Kanban board where I can go like, this issue is now in progress, or this issue is now in review, or this is now whatever. I click somewhere, whatever. I can resolve the issue. And this is really just a log that you can use. This Kanban board is going to be directly linked to your repository, and issues are going to be shown on there. It's very convenient. If you use that for for just people to collaborate to work together, it is an awesome thing. And I need to go back to. Did I have anything else on there? Fork, we said, branch, clone, switch branch. Yes.
How do you know it's being kept?
Good question. They go through my repositories because I have a lot of other inactive. There, as you can see, this one was updated 8 minutes ago. So you can really see the activity. You have a couple of ways to see activity there through this graph. That's a graph of all the commits through time that happens. So for example, I did not update this repository since 2024. So this is very inactive. And you can see that the last commit was 2 years ago. So if this were an actual code base, something that's maybe critical where I needed to be updated often for security reasons, I wouldn't use this product. And yeah, does anyone have any other questions about anything? I talked about a lot of things and we're still waiting for the pizza. It's not. Yes. So branching, yeah. So you're gonna want to use a branch. If you're working alone on a repository, like you're the only one making changes, it's not necessarily the most useful thing to make to create branches because you're most of the time gonna work on more like one or two things at the same time. But let's say that, for example, at some points you want to you want to start working on something that you know is going to require a big refactor of the code base, but you also want to work on another feature at the same time. Like, this is a very long-term project, and this is like very short thing. What I can do is I can keep this be the main branch. I can branch it. I can do whatever I want. It's not going to affect the main branch. And whenever I'm ready to merge it, for example, I go from V1 to V2, I can merge it. And so like this is useful when you work on a lot of things at the same time. I have another good example of this actually. So a repository that I'm the main maintainer. I have two branches on there right now. I have main and I have this test branch. The reason why I have this test branch, GitHub allows you to, if you go to this actions tab, GitHub allows you to basically run checks on your code or like build your code and upload it somewhere whenever you make a commit, whenever you push something. And I am able, if I go to the exact pipeline, I am able to say that this thing right there, this process is going to run whenever we have an event that is a push on the main branch. But if I ever have a push that is and that is on a test branch, like this is what I'm doing there. I'm basically going if the name of the branch starts with ref/head/test, then we're going to do something else. So this is another use for different branches. And so on this repository, the main branch really is the clean thing. Well, the test branches, I'm just testing random stuff. Does that make more sense? Yeah. And yeah, if you're interested in what's yeah, okay, this is a pretty good one. If you're confused about something on Git, you can just type out Git cheat sheet, and there, there are a couple that I didn't go over, but like for example, Git clone, Git add is right there, Git add dots. What do we have as well? Git status, Git commits, Git switch, Git branch. We have just look up a cheat sheet is super useful because Git has a lot of commands and you cannot keep track of all of them. And subcommands list. Can I find a good list of all the subcommands that there is? I guess in the reference. Yeah. Yeah, this is not a complete list of all commands. There we go. So I said that there were a lot of commands. This is all of them. it still keeps going. This list is long. There's a lot of it's interesting to go through this list. To go for example like uh I s- do I see something that is interesting? Git cherry, for example, that's a pretty interesting name. What is this? And it's a way to find commits that are yet to be applied, that are yet to be pushed on GitHub. So like if I have a lot of commits locally, I can just use a Git cherry to find the commit to find these commits easily. And there are just so many different ways to use Git. It's an awesome piece of software.